Okay, we're going to start with something very simple. Right, today I'm going to be working questions 21 through 24, but we're going to find very, very simple. If A and B are independent, so these two events don't depend on the other. I know yesterday we talked about lightning and rain, and there's basically a combination of those. But now let me ask you this. Probability of you eating something. I don't know, let's say probability of you eating carne asada, right? Grilled meat. Does the probability you're gonna eat carne asada, whatever your neighbor eats, does that affect what you're gonna eat? Not necessarily, right? You and your neighbors are different families. Sometimes you guys might share food, but most of the time, whatever your neighbor eats does not affect what you're gonna eat. That's what we call independent. So if A and B are both independent, here I want to ask you what's the probability or find probability of A given B? Since B does not affect A, let me cross this out. Since B does not affect A, really I'm just going to find what's the probability of A happening. In this case, the probability of A is 0.21. So that's going to be my answer, 0.21. Because A and B are independent, I don't care what happened with B. I don't care what happens on the second one. So what that means, if I had given you what's the probability of B given A, we cross out the second one and I would have asked for probability of B then. Let's take a look at another example here. If A and B are independent, find the probability of A given B. Again, I crossed out the second one. So I'm really just going to look for probability of A. In this case, 0.55. I said we're going to start with something very simple. Now let's move on to questions 23 and 24. Let me flip my page. It says Mrs. Ivanka provided after school office hours for her students. On her last test, 38% of her students attended office hours. Overall, 52% of her students attended office hours. Approximately what percentage of Miss Ivanka's students passed? Oh, 38% office hours and passed, and 52 attended office hours. So let me just take a look at the percentages here. What it's telling me is probability. Actually, I'm gonna do this in black. Probability. So I'm just gonna read my first part here. 38% of the students attended office hours and passed. So I'm gonna say probability of they did office hours and passed is 0.38. I'm gonna write it as a decimal because it's easier for me to type on the calculator. And then it says overall 52% of her students attended office hours. So the probability of office hours is 0.52. That's really what it's telling me here. Now, approximately what percentage of Miss Ivanka's students pass given that they attended office hours? So here it is asking me what's the probability that they pass given they attended office hours. So I remembered pass given office hours. I'm looking for probability of pass and office hours divided by probability of office hours. Remember, the second one is the one I'm going to divide by. Okay, past and office hours is 0.38. Because remember, the way we read this is office hours and pass, or we just flip it, pass and office hours. Now, the probability attended office hours or probability of O is 0.52. Okay, I divide this 0.38 divided by 0.52, according to my calculator, is 0.730. My third decimal number is small, so 0.73. Now, one thing here, probability-wise is 0.73, Probability, it's a number between 0 and 1, so it's always 0 point something. But here, my question here it is approximately what percentage? Ooh. So I'm not asking for this as a decimal. I'm asking this as a percent. Remember, the way we read this is I have read it in previous assignments. I don't know if you noticed this, but I say, oh, the probability of 0.73. So that means that's 73%. So I'm just going to write 73. I'm not going to write the percent symbol. I'm just going to write 73. What this thing is asking me is 0.73, that's the probability. Probability is a number between 0 and 1. Now here it's asking me in percentage. So read it as a percent. What's the percentage of this happening? Well, 73%. Okay, let's take a look at another example. In a city initiative, drivers were encouraged to take a safety course to reduce accidents. Over the next year, 32% of drivers took the course and had no accidents. Okay, so how am I going to abbreviate this? Let's go probability. They took the course, so I'm going to write C and no accidents. Okay, let me write as N, no accidents. So probability that they took the course and had no accidents, let me write this as 0.32. Overall, 53% of the drivers took the safety course. So probability that a driver took the course is 0.53. Approximately what percentage of the drivers had no accidents given that they took the safety course? So basically, I'm asking probability of no accidents given that they took the course. I know I have to go probability of no accidents in course divided by probability of the course. So I have to go 0.32 divided by 0.53. According to my calculator, that is 0.603. The third decimal number is small, so I'm going to ignore it. So if it was asking, probability is 0.60 or 0.6 because it's asking what percentage. I'm gonna call this, remember, I could call this 60%. I just don't want you to be writing the percent symbol. So just 60 is enough.